Our next work is to classify the digits using the built-in commands of deep learning toolbox. So far we had done this once already, right? The similar target we had achieved, right? But there we used to write the CNN code by ourselves, right? So we didn't use any of the built-in functions. Instead we wrote the function by ourselves. Okay, so that's what we did earlier. But now you see, right, in our current work, what we'll do here is we'll try to write the we'll use the inbuilt command. Okay, we'll use the inbuilt command and we'll try to achieve the same target. Okay, and then we'll try to compare. Okay, so as you can see here, I created another folder called CNN digit classification. So there we have the data set, right? The data set which we had considered earlier, same data set I have. I'll open that and show. So you have the digits starting from 0 to 9. Okay, there are 10 classes. So inside each class, as you can see, right, it starts from 9001. So 001 you can remember, and goes all the way till can you see on the leftmost side? I'm actually right on the leftmost side, the current folder. I'm talking about the current folder. That's visible, right? Okay, so you see the data set is like this. So it's, again, I'm showing for digit 0, but definitely you have other data sets as well, like for data digit 1, 2, 3, 4, and so, right, all the way till 9. Right, each class, how many data? You have 1000 data, right? So we have sufficiently large number of data. So the total data strength is 1000, one class 1000. So I have 10 such things. Okay, so 10 classes. So totally 10,000 is the data set strength. Is it okay? So that's our data set. All right, so we'll start coding by bringing up a new script file. Okay, so edit my digit classify. So that's the one which we are going to open. Okay, right. So first I need to say that where is my data set, correct? So the data set is fine. So let's try to write the data path. Okay, so I'll start creating from here. So here, close. Then now I'll create the data path. Okay, so I need to say where is the data, right? So as you can see, the data is present. This will be the path of the folder, as you can see at the top. I'll copy that and I'll write it here. Okay, so the data path is starting from till here. Okay, CNN digit classification. Inside that I have another folder by the name digit data set. Okay, digit data set. So I'll close this. I'll press. So that's the data path. Now, as you can see, since the data set is divided into subfolders and each folder name is given in such a way that represents the class name, correct? So it means I can directly create what is called as a image data store, correct? So we'll do that now. So I am ds. The data store, if you remember, we had used this already once. Okay, so what's the command? Image data store. Then I need to specify where is the, what is the path. So path is data path. Okay, that it's located over there. And then I need to specify what are the various parameters of this data, whatever data store it is. Okay, so that is, so image data store of the data path, you have to say, right, I want to include the subfolders, right, because I have many folders, each folder name itself is a class. Okay, so include sub folders, and you should say it is true, I want to do that, or even you can write one, right, it include this. And then I need to say that each of the folder name is a class name, right, so that can be done by using label source, comma, folder names. So that's what I wanted to define. All right, let's try to run this and see. So a image data store needs to be created on the, in the workspace. That's what we require. Okay, it's done now, as we can see there, right? So image data store has the complete details of the database. Now I'll try to check that whether the data store is proper, and I also want to see in what format I have the what you call the data. I want to visualize the data. As you know, this is a data set, it contains image of handwriting, okay, handwritten numbers, digits. Okay, I want to verify that what, how is it, how the data is present, what is the size of each image, etc. I want to check. All right, so let's do that now. So image data store has the complete address of the each and every file that is present over there. So we'll call a figure. Okay, I'll create some say I want to visualize randomly selected say maybe 25 images possible. Okay, we'll take 25 images randomly, I'll choose. So what I do, I create a random number. Okay, so the number p is equal to, so you know that we can use what a function called as randperm. I'll show you what is it. So this is, so there is a randperm, it's a random permutation. You can create a set of numbers as per your requirement. You see, randperm of 6 means 6 numbers will be created at random, right? So like that, I just want to create that. So randperm of, now you see, I want to create I have a maximum limit here. I don't want to create any number which is outside my range. The range I'm talking about here is the range is the maximum number of images you have. Each class 1000 image, 10 such classes, so highest number is 10,000. So I want to go with the maximum number 10, right? Then you tell how many out of, starting from 0 to 1 10,000, how many numbers you want to create. I just want 25. So that's what is this. Okay, I want to plot randomly selected 25 numbers, that's all, 25 images in from my data set. Okay, so for start I is equal to, start from 1 and go all the way till 25. Okay, during this, go for a subplot. It's 5 rows. You can arrange it in any way you want. Okay, but I prefer 5 rows, 5 columns, out of which the ith image. Okay, before that I will do a figure over here so that Okay, it creates a new figure, right? I create a new figure. I go to a subplot 5 comma 5 comma I, and I'll do the IMSHOW because it's a image, right? I want to show the image. Data set contains image, right? So it's not a plot, it's an image. So what you want to show, which image it is present in IMDS, the data image data store. I'll just open the IMDS and tell you what exactly we are looking. So in the IMDS, we have what is called as the files, right? That file is 10,000 into 1. So in which I may select any of the 25 random numbers. So if my selection is 51, right? 51, 51st file should be shown, displayed. Okay, 51. So IMDS dot, what is the name of the variable which holds the count of the files? It is files itself. Okay, IMDS dot files. Now you see that is a cell. Okay, so cell structures are you can access that by using the flower brackets. Okay, PE or sorry, it's not a what's the name given? P. It's a random perm. So random permutation is assigned to P. Now I am reading P of I. Okay, so I'll close this. Then there is another bracket. Okay, this looks like done, and I'll repeat this 25 times. That's all. Okay, so let me okay, let us run everything from the beginning and check. Can you see? Okay, there is a figure which popped up. Okay, and it shows the various digits. Okay, right? So you see H91960 in various formats. It right? We have it, right? So that is the figure which we were talking about, and we can see the figure like this. So 5 into 5, totally 25 elements. You can plot as many number of data sets, images you want. You just change the number and change the way in which you want to plot. All right. Okay, so that's the second part of the code in second section of our code. Okay, so now what we do now, let's go ahead and let us try to add another section over here. And in this section, I want to start, maybe I want to create a label as well. Okay, so we'll do the label count, that is equal to count each label of, right, that IMDS. So inside that IMDS, how many labels we have, I just want to see. Okay, so let's try to run this part of the code. So it will be displayed. You can see there, right? So it's a table, right? What is a label and how many, what is the count of files inside that label? So I have a class called 0, 1000 images, right? Class called 1, another 1000 images, like that. I have total 0 to 9 classes, totally 10 classes, and each class has this. This is the detail I get directly from this. Okay, and I just want to right, see the size of an image, right? So what I'm going to do now, so read a specific image from that. Okay, maybe I'll call it as img image. Img is equal to, see, the command is read image from the data store imds, and say first image. I don't mind reading any of the image. Okay, imds is equal to this, and look at the size. What is the size of each image? I want to know. Can you tell me why I need the size? what happens if I don't know the size, right? Where I may have problem, in which part of the code I may have some problem if I don't know the size. Size of each image. It says that it has 28 rows, 28 columns. Okay, so previous one was a label count. A label count told me how many labels you have, how many classes you have. I have 10 classes, and each class has how many images I could understand. Okay, that was the previous case, and now I am running the size of this image, size bracket img, that tells that it is 28 comma 28. Okay, no problem here right now. As of now, I don't have any problem, but I have a question there. What I asked was, right, what if I don't calculate the image and I proceed with my regular coding? Which step of the code I might face some problem? Where do you need the size? As you remember, we are trying to write a code that implements the convolutional neural network. Okay, where do you need the size of the image in that case? Which part of the code requires the size to be known? Or is it okay even if I don't know? Okay, no problem. I'll answer that as soon as we come to that point. Okay, till then you can try to recall. All right, no issue, absolutely fine. Even if you cannot recall, absolutely that's fine. Okay, fine. I also now I know that I have 1000 files in each class. Okay, out of which, let me say I want to use uh, say 75% for training and validation, maybe. Okay, so what I do, I define number of training uh, images. Okay, imgs, number of training images equal to, I'll define it as 750. Again, this is for each class. Okay, and there is a function inside the Matlab, right, which can automatically, right, split your image data store according to your ratio. You define whatever ratio you define, you can use it. So that's what I'm going to do here, right? So I need the image data store for the doing the training, and image data store for validation. Okay, imds train and imds validation is equal to split each label. So this is the function used. Okay, I just have to say, right, from where you want to do this splitting option, right? So the splitting option should be, right, from imds image data store, right? And what proportion you want to do, you already have defined that, that is num train images, num train images, right? Then you will say I want to do what is called as a randomly you select. You don't go with the uh, sequential process, right? Do it randomized. So randomize. All right, let's close this. That's done. All right, then okay, I can understand that. Okay, okay, fine. Let me try to run this part and see what happens now. There'll be an error. So till here, no problem, everything is done. Okay, so let's move ahead and let me define a new section in the code wherein I want to define, right? Everything is ready. We have the data set readily available. We divided that into required portions, right? So let us start writing about the layers. Okay, so layers is equal to, what is the first layer? First layer is going to take the input, right? and the input will be an image, right? So what is the layer name? If you recall, it is image input layer. So image input layer, tell what is the size. Now you see, if you don't know the size, you are stuck. Okay, this is the point, right, where you need to know what is the size. So that is 28 rows, 28 columns, and one such page. Okay, so that's the size. Okay, so that is done. Image input layer is over. Then I would like to define the next layer. What is the next layer? It will be a convolutional layer. Convolution 2D 2D layer. So I will choose, right, 3 cross 3, and 8 is a stride. I just want to define, say, do you want padding? Yes, I want padding, and I want to do the padding in such a way that the size of the result remains same. Okay, all right, so that's the next layer we defined, convolutional 2D layer. So immediately after convolution, I should perform a normalization. So that is batch normalization layer. Activation function relu. All right, right. So okay, then here I don't have to write the, I don't have to follow this rule of I don't need this, I guess. Even if you don't write this, it will say, it will not give you any error. Okay, so I can actually it's a facility given just to show that you can separate your layers. Okay, so I'll show you what exactly I mean. So I'll just erase these dots and the, right. So you see, you don't need that. It's not an error. Okay, it's not going to throw an error. So what I do, I'll repeat this. So once this is done, I'll go for a pooling option, right? So that will be like max pooling. It's a two-dimensional, so 2D layer. So how the pooling happens, you need to specify what type of pooling you want. It is max pooling. So size should be specified 2, saying that it is a 2 cross 2. Do you need a stride? So the answer is yes. For the size, stride will also be 2. So this part I need to repeat now. So whatever we have written here, we'll repeat. Okay, so just see, this is what I want to copy. So if you remember the thumbs rule over here, so the change is that in the upcoming layer, so in the convolutional layer, the number of filters will increase. That becomes 16. Okay, so padding, same, batch normalization layer followed by that. Then what you have a ReLU layer, and again use a max pooling layer of the same capacity. All right, so go ahead and do this again. Okay, so you see, it's a third copy I'm writing. So previous layer has 16 such filters, so I'll go for double of that, so that is 32. Okay, so batch normalization, ReLU. Then if you are taking your output, you don't have to write what is called as sorry, just a second. So if you are taking an output, then you don't have to write this part. Okay, so you don't need the batch normalization in the final layer. Instead of that, use a fully Connected layer. Fully connected layer, right? How many classes you have? So many, right? That's what it is, 10, right? What is the output function of your what is the activation function of your output layer? It is not ReLU. If you remember, right, it's not ReLU. Which is that? Can you try to recall? If you have written somewhere, just refer and try to answer that. Which is the output, which is the activation function of our output layer? What are the other activation? If you try to recall their names, maybe you will get you'll be able to recall. ReLU is not required at the output because, right, it actually passes everything. That the error generated over there will be passed to the previous layer without any problem, right? Whichever layers you have problem with passing or back propagation of the error, there you put the ReLU. So that's the reason why we are not going to put ReLU in the final or the output layer. Okay, so which is the one? Have you heard of softmax? Right, so the softmax layer will be used. Okay, then the final layer is a classification layer. Okay, so these are the layers which we have defined. Anyway, we know that, so I don't want to give a name, and right, I don't want to uh, see the layers. Anyway, I know that if I plot it, I will see this, right? So I don't want to plot here. I'll directly go for the options. Right, options in the sense you want to tell what are the options you want to do during the training. So this is defined by using a command, training options. So specify what is your method, SGVM, comma, that's one of the famous algorithm to be trained. We used to train, so I'll keep it as it is. Then you will specify what is the initial learn rate. So initial learning rate can be specified. So let us specify that to be 0.01. Again, this is the initial value. Ultimately, machine is going to change this as the learning progresses. Then what is the other option you can specify? I want to specify about the maximum number of epochs. Okay, so maximum number of epochs, let's keep it say 5. Let's see. Okay, uh, then do you want to have shuffle them? So the answer is yes. Right? If you don't want to shuffle, you don't have to write this line at all. Okay, so this is shuffle. I will say you need to shuffle every epoch. Shuffle the data during every epoch. Okay, so that is done. Then, okay, should I validate is my question. So my answer is yes. So we'll go for validation data. Sorry, validation data is a keyword. And I want to say that yes, I want to validate. I think we have separated certain data for validation. You see here it is present here, IMDS validation. Okay, so validation data will be IMDS validation. All right, so once the validation is done, I have to specify how frequently you want to do the validation. So this is validation frequency, comma, So specify every 10 I want to do this. All right, then I want to visualize, right, the performance as and when the training happens in the form of a table. So if you remember, the keyword is verbose. Okay, so I will say yes, I want to see that. So you can write 1, or even you write a true, it's fine. Okay, then the next option I want to see is about the plots, and just tell what you want to see. I want to see the training progress. Okay, so that's the option. So as soon as you finish this, specify the options you want to use for training. Directly go for a training. So the output of the training will be saved in the variable net. So TRAINNETWORK, train network. So specify what you want to train, right? This is which is the data, right? The data I want to train is IMDS train. Okay, then tell what layers you want to use and what options. What are the options? Okay, all right. Now let us check this part of the code, and let's verify how much uh, the training has happened so far. Okay, it will take some time to start the training process, right? Okay, we'll wait until then. So we can see that the verbose has begun, right? So in the command window, we can see, right? It's visible, right? Okay. So meanwhile, I'll try to bring up the figure that corresponds to this one. The training progress. Okay, let me just open that. Okay, so you can see that it's saying that validation and frequent accuracy of 99.48%, right? After 5 iterations, correct? All right, now let us try to go back. Okay, so that's the training part. As of now, it says that it's a good training. All right, so let's go for the testing part. So in the testing part, I will go with the prediction, the prediction, right? Whatever the machine predicts, so I'll call it as, say, the y predicted, right? I have to use the keyword, the function called classify, right? What I want to classify, I want to classify using the net, that is a neural network, and IMDS, the validation. VALI validation. Okay, now I just want to get what is the actual answer, right? So that is y test is equal to the IMDS validation dot, see, there will be the labels saying that yes, this is the right answer. So right answer is present in y test, the what machine predicted is present in y predicted. So I just need to calculate the accuracy, right? Accuracy is equal to, see, the same this thing. I want to check that, I want to calculate the sum of all the classifications which are correct. Okay, so that is y predicted equal to the y test. Take a sum, divide that by numerical length of the total data you tested. Okay, so that is maybe I think y test, okay, or y predicted, right? That gives you a fraction. So what I do, I'll multiply that with 100. Okay, so let's quickly check this part of the code. So it didn't show the accuracy. Once again, let me run. Yeah, so you can see that, right? I can see that accuracy is 99.48%. Okay, so let's do one small change here, because what I did, while doing the validation, I used the testing data over there. So that actually is a mistake. Okay, so validation data is actually, uh, I don't have separate test data, right? So that's my mistake here. So I am supposed to do a small change. IMDS stain, and this will be changed to IMDS test. Okay, IMDS test. So everywhere it is just IMDS test now. So let's run, and if there is an error, we'll rectify. Okay, so I'll run an advance, run an advance, run an advance. Okay, I'm able to visualize, that's fine. Then you created training data and the testing data, and here there is a problem. Okay, so this is no problem. Okay, so here, instead of the validation should not be done with the testing data, should be done with the training data, IMDS train. Okay, so validation frequency is this. Let me increase this to, say, a 10 and see what happens. Okay, initial learning rate also I'll try to, that's fine. Verbose is 1. Okay, let me try to run this section now. Again we train, right? And right? Maybe there will be a small change with respect to the final whatever result. Okay, so the training progress can be seen as a verbose, as we can see below, correct? Okay, so now you see it says that validation accuracy is 100, right? Now you see the data which we are going to use for the testing, right, is completely unknown to the machine. Previous case, that was not the case. Okay, whatever you are going to use for testing, right, it was actually known to the machine. So I just wanted to avoid that. Okay, so just to avoid that, I didn't give the testing data to the machine so far. Machine does not know any detail about the testing data. Okay, right, now we'll do the testing part. Now you see I pass the testing data to this. Okay, y test is equal to the labels of the IM test, and I'm comparing with them. Okay, so let's try to see what's the result now. Yeah, so slightly there is increasing. It was 99.48, now it is 99.88, right? So anyway, we didn't do much change, but the result is already good, right? And maybe we don't have to change anything over there. Okay, so that's our idea, right? But anyway, definitely you can change here. This you can make it as a 700, and remaining 300 will be used for testing. You can try with various ratios, 60/40, 80/20, like that. 800, if you enter, 200 will be used for testing. So normally what happens, more training you do, more and more will be, right, there will be what is called as learning rate will be better, right, and more updation of the weights, which causes better results. Okay, so that's how you try to write a code. Now this actually includes everything. We could go faster because since you already know what we are exactly writing and what will be the flow of the code that we are going to write, so we could write it quickly, right? So next, maybe I'll try to give it's just like a like you can try, what you can try, you collect your own data, right? Like 10 different classes, like take say 10 pictures of different types of chairs you can get. Okay, put it inside a folder called chairs, right? Maybe you can collect hundreds of data from Google directly. Go to image, search for chairs, collect. Okay, make another class called tables, right? Collect say maybe similar number, 100 numbers of tables if you can, right? Table photos, right? Also you can get add few more classes like dog and cat, right? You see, right? Just give the folder name by that name, that's all, right? Give a name and store. So maybe you can generate, now here it's just a digit data set, but you can definitely create a data set which you want to classify. Maybe, right, hundreds of data can be present inside each class. Like that you can have 10 is already done. Go for a bigger number like 20, 25 classes, or if you can go to 50, that's good. 50 different classes, each class has say hundreds of images at least, right? Make that as a folder, and the change that you're supposed to do here is just this one. Say where are those folders present. Okay, so that's what you need to change. Do not change anything else. The next change that you are supposed to do here is the size of your image. It depends on what size, right, you have, right? If all the images are same, you can simply change this value to that specific size. Okay, so then I don't think you have to change anything later. As it is, it will run. But definitely, if you want to make some change, you can change the number of layers here. I define this as say, right, a smaller number. You can start from smaller number also. You can have just 4 here, then 8, then 16, and so on. You just have to another set of layer, add another set of layer at the end. By doing so, right, you will be able to design your own convolutional neural network, but not by writing the code from scratch, but using the optimized coding that is available in the form of built-in functions in Matlab, okay, under the deep learning toolbox. That's all. So whatever we have used here is like that. Okay, so by doing this technique, you will be able to write the code for classification of any data set you have. You can try by yourself, okay, and let me know if you need any help in that part.